All right, so you guys asked about this question in class today, and I didn't get a chance to do it, so I want to make sure we cover it now. So I believe this is the question that was asked. If not, it's very similar to it. So it says, find an equation of the line that's tangent to the graph. Okay, so I'm looking for a tangent line. Tangent to the graph of f. And parallel to the given line. Okay, so what does this tell me? Well, I'm looking for a line that's parallel to this line. So what does it mean if lines are parallel? Well, if you go in the same direction, they'd have the same slope. So I wish I knew what the slope of this one was. And that's easy enough to figure out. If I rearrange this equation, I could get y equals 3x plus 1. I can tell that the slope is equal to 3. Okay, awesome. So how does that help me? Well, so find the equation of the line that's tangent to the graph of f. So I want it to be, actually I know what x cubed looks like. So it looks like this. And I want a line that's tangent to it and is parallel to this other given line. So, 3x plus 1 might look something like this. So I want them to be parallel. So I want them to have the same slope. So I want to find a line, a tangent line to f that has a slope of 3. So I really want to find a tangent line to f of x that has a slope of 3. Because, right, keep in mind, the tangent line and the line are parallel, so that means they have to have the same slope. So I want a tangent line that has a slope of 3. Slope of a tangent line. Rate of change, instantaneous rate of change, derivative, all of those things, right? So I really want f prime of x to equal 3. Okay, well, that's simple enough. So, what do I need? How would I figure this out? What x would make that happen? Well, it'd be nice, if I go ahead and I take my derivative here, right? So let's take my derivative. So I know that f prime of x is equal to 3x squared. All right, what do I want? I want f prime of x to equal 3. So I really want, 3x squared to equal 3. So I want x squared to equal 1. So I want x to be positive or negative 1. And that makes sense if you come over to the graph because, we have one here that looks like it would be parallel to the purple line, but we also have one back here that would be parallel to the purple line. And so we actually have 2 lines. All right, so what was I trying to do again? So it says find an equation of the line that's tangent to the graph of f. So I want the actual tangent line equation. So these are 2 spots where I would have a tangent line. Now I need to find the equation of the line at both of these spots. All right. So what do I need to know to write the equation of a line? So let's do x equals 1 first. Well, to write the equation of the line, I need the slope, which I have, right? The slope is 3. We already knew that. I also need a point. I know the x. It's really easy to get the y. So, right, I'd have the point 1. And if I plug that in there, I get the point 1. And so I know that the tangent line at x equals 1 has to have a slope of 3, has to go through the point 1, 1. So it's going to have the equation y minus 1 equals 3 multiplied by x minus 1. And then similarly, the point at x equals negative 1, well, that still has a slope of 3 because it's got to be parallel to, that other line. And I know that the point on it would be negative 1. And if I put that in, right, to figure out what the y value is, because that's the point of tangency, that's where they'd be touching, right? Get the idea, maybe. Right, that's the point that it actually passes through. So I plug negative 1 in there, I'm going to get negative 1. And then I can go ahead and write my line. Y minus negative 1 minus negative 1. That's really y plus 1, right? Equals 3 multiplied by x minus negative 1, which is really x plus 1. And And so there is one of my tangent lines, and there is one of my tangent lines, and I have two of them, and those are both parallel to the given line, and they also pass through f of x, so they're tangent lines that have the same slope as that line. Hope this helps. See you tomorrow in class.